You're about to see a Lapidary demonstration. Lapidary allows the designer to pictorially specify all graphical aspects of an application, including the widgets that the application uses, as well as the application graphics themselves. Designers can also interactively specify any application behavior. No other interface builder allows the designer to specify the insides of application windows.
Lapidary is part of the Garnet project at Carnegie Mellon University. Garnet is a comprehensive user interface development environment that makes it significantly easier to create highly interactive graphical user interfaces. Lapidary is an acronym and stands for List-Based Assistant for Prototyping Interface Designs, allowing remarkable yield.
In this demo, I'm going to change the look and feel of a menu and then create several application-specific graphics, such as boxes and arrows. Lapidary runs under Common Lisp and X and takes advantage of multiple windows to present different kinds of information. Our first task is to change the look and feel of this menu to the look and feel of this floating button menu. First, we will remove the old feedback objects. The menu's look and feel can be changed by modifying the menu item's prototype. Lapidary uses a prototype instance model in which instances inherit both data and structural components. This form of structural inheritance is novel among interface development tools. Thus, when I add the rectangle I've created to the labels aggregate, each of the menu items automatically inherits this new component. The menu strings can be centered within the buttons using constraints. A constraint expresses a geometric relationship between two objects, such as centering. Constraints are automatically inherited by instances of a prototype. The button should appear to float above the display, so I will add a shadow to the prototype button. Lapidary provides iconic menus that define the most commonly used constraints. The icons with black boxes correspond to the object with black selection handles and represent the object to be constrained. The white boxes around the white rectangle correspond to the object with white selection handles and represent the object that the constraint references. Notice that Lapidary's explicit use of constraints differs from the peridot model, in which the appropriate constraints are inferred from the relative positions of objects. At this point, I'm ready to demonstrate the button's behavior. In Garnet, the behaviors are specified separately from the graphics using special interactor objects, which Lapidary creates in dialog boxes. The designer can set parameters like which mouse button starts the behavior and the application function called when the behavior completes. Here, we are going to demonstrate the interim feedback by demonstration. The interim feedback describes what happens as the mouse is moving, and final feedback shows what happens when the mouse stops. Lapidary creates a copy of the selected object and places it in a demonstration window. I will first edit the copy so that the white rectangle covers the black rectangle. Lapidary will then compare the original and the copy, figure out differences, and generate code to implement the changes based on the position of the mouse. The final feedback should be a black XOR rectangle that highlights the selected button. Notice that, like the other examples in the demo, this example uses the iconic constraint buttons. In practice, the constraints represented by these buttons are almost always the ones designers need to use. However, if designers need a different constraint, they can choose the custom constraint button, which will give them access to a spreadsheet for specifying constraints. The final feedback option causes Lapidary to generalize these constraints so that the feedback can appear over any button in the menu. Constraints are generalized by replacing direct references to objects with indirect references through variables. By changing the values of these variables, an object can be constrained to different objects. The menu can now be added to an application. As demonstrated, the buttons bounce up and down, and the black rectangle inverts the selection. Of course, a designer is not restricted to creating objects from scratch. Designers can create instances of predefined gadgets from prototype libraries, place them in Lapidary's drawing windows, and modify either the graphics or behaviors as they see fit. In this example, a two-dimensional scrolling window will be constructed from Garnet-style widgets. The horizontal scroll bar is not wide enough to fit the window, so it is appropriately resized. Similarly, I can create instances of other prototype widgets and customize them as well. Although it is not shown, the designer can modify the look and feel of these instances. Thus, the designer could add additional decorations such as a background, physically alter the instance by adding or deleting components, or change the widget's behavior by using the appropriate interactor dialog boxes. While other interface builders also allow designers to choose widgets from a prototype library, they typically provide only one look and feel, which cannot be modified by a designer. Although this promotes uniform interfaces, it discourages experienced graphics artists from prototyping new looks and feels. One reason Lapidary is such a powerful tool is that it allows designers to experiment with different looks and feels. But a more important reason is that designers can create the graphics inside the application window, which I will do next. I would like to create the data and arrow objects for an arithmetic editor. The data object is created by sweeping out a rounded rectangle and entering a sample number. This number's readability can be significantly improved by enlarging its font, which is done using the Text Properties window. The Text Properties window also allows the designer to make the value of a string depend on a constraint, which is useful for relating an indicator on a gauge to a property of an application object. The rounded rectangle should be centered around the number and be just large enough to contain the number. The use of constraints ensures that the rounded rectangle will expand and shrink as the number expands and shrinks. The label and the rounded rectangle are next grouped together in an aggregate, which is named data object. Finally, the prototypical data object is saved to a file so that the arithmetic editor can load it and create instances of it. A prototypical operator object could be created in a similar fashion. Now I will create a second data object so that I can create an arrow and demonstrate the arrow's behavior. When I rotate the arrow in the constraint menu rotates as well. This makes it easy to determine which endpoint of the arrow I am constraining. In this case, the arrow's left endpoint is attached to the right side of an object, and its right endpoint is attached to the left side of an object. These constraints are dynamic constraints, since the arrow will stay attached to the data objects if the data objects are moved. As I've saved the arrow, Lapidary notices that the arrow's constraints reference objects that are not being saved. Lapidary infers that these constraints should be generalized so they can reference any object. And with my permission, it replaces direct references with indirect references. This portion of the arithmetic editor specification is complete. Next, we would use Lapidary to create the other objects and the interactor for entering numbers. Then a programmer writes the application functions for doing arithmetic, and the application is ready for testing. The application uses instances of the prototypes Lapidary just created. Notice that the rounded rectangles expand as numbers are input, and that they stay centered around the numbers as specified in Lapidary. The user can move both operators and data around, and the arrows will stay attached to these objects as dictated by Lapidary. Lapidary can be used to generate many other types of objects and behaviors as well. We can support single or multiple selection, where multiple selections automatically duplicate the feedback object. A designer can specify that these menu items change font by demonstration. The feedback for selecting application objects, such as these Macintosh-style selection handles, can be created. Box and arrow editors can be easily specified using Lapidary. Behaviors, such as the inputting of text strings or the repositioning and resizing of boxes, can be specified just as easily as the graphics. Lapidary-defined constraints force the arrows to stay centered within the labeled boxes, even as these boxes move or change size. Finally, Lapidary can construct more complicated application objects, such as this truck. The mileage indicator is constrained to the truck's x-coordinate, and the truck's weight indicator depends on the slider. As the slider goes above 75% of the truck's weight capacity, the truck's color turns to black. Lapidary allows the behavior of each of these graphics to be specified by demonstration. Even inexperienced computer users can rapidly generate highly interactive graphical interfaces. Thus, Lapidary takes a significant step forward in the evolution of user interface development tools. Thank you.